Hello students, welcome to ShirtBack Academy. In our lesson today we're going to be covering section 2.5 in the ITF Plus course. Our topic for this lesson is common storage types. Let's begin. Our first storage type is local storage. Local storage is a hard drive or solid state drive that retains data internally on a computer, or also it can be directly attached to peripheral devices. Local disks are partitions within the storage drives that will identify the data on the device. The most common local disks are the C drive, D drive, and H drive. The C drive is used to store operating system boot startup processes. The D drive will store data backups, and the H drive acts as the home directory on the local hard drive. Local storage does not require an internet connection because the resources we need are on the computer itself. Local storage does have automatic backup features if we need them. Volatile storage is data storage that requires an active power source to the device. Volatile storage is usually temporary memory that we use to store application and computer processes. The two most common volatile storage types are random access memory, or RAM, and cache memory. Non-volatile storage is a memory type that will retain its data after the power supply is turned off. This is a more permanent data storage type. The most common non-volatile storage types are hard disk drives, read-only memory, USB sticks, and solid-state drives. RAM memory stands for random access memory. RAM memory is volatile storage that provides temporary data memory for all running applications on the computer. RAM memory provides the user fast data access and retrieval, but will not run once the device power supply is turned off. Memory is measured in either megahertz or gigahertz depending on the speed. RAM memory will use a memory card form factor. These can be built in on the motherboard or added as expansion bus cards. Some common RAM types include dynamic RAM, DDR4, and video RAM. Hard disk drives, commonly abbreviated as HDD, are magnetic non-volatile storage that uses rotating platter disks. Hard disk drives have multiple circular disks called platters and an actuator arm that controls the disks while spinning. Here to the right is a screenshot. We see the circular platter disks and the metal actuator arm. Hard disk drives can reach rotational speeds up to 15,000. The two most common form factor sizes are 2.5 and 3.5 inches. Hard disk drive parts are breakable, but replaceable if the damage is local to one disk. If multiple disks are damaged, we need to get a new hard disk drive. Solid state drives, or SSDs, are non-volatile memory with no moving parts or spinning disk drives. They provide very high processing speeds. Several common form factors include 1.8, 2.5, 3.5, and 5.25 inches. Solid-state drives provide their storage using a grid of flash cells. This technology works similar to RAM memory with quick data access and retrieval. Hybrid drives are a combination of solid-state and hard disk drive features in a single device. Hybrids can use both volatile and non-volatile memory. The solid-state drive component of a hybrid drive will cache the slower spinning hard disk drive data to increase the device speed. hybrid drives have similar appearances to a hard disk. The two most common form factors for hybrid drives are 2.5 and 3.5 inches. USB flash memory drives use non-volatile memory for data storage. USBs do not require a power supply, and they have gigabyte and terabyte data storage capability depending on the model. USBs have limited writing capabilities. Some data must be read-only. USBs are not designed for permanent storage, so backups are necessary. The most common flash storage USB connector is USB-A. An example of USB is the flash drive on the top. However, USB-C is becoming more widely used. That is the flash drive here on the bottom. USB-C is different because its connector is what's called asymmetric. We can plug it into the slot either way. Optical storage disks are flat circular disks that store data through laser stamping. The data is accessible by spinning the disk and reading the data from the inner to the outer grooves on the disk. The three main optical data types are CD-ROMs, DVDs, and Blu-rays. CD-ROMs have megabyte storage. DVD-ROM has a 4.7 gigabyte single-side storage, and Blu-rays have 25 and 50 gigabyte storage on either a single or dual-sided disk. Network attached storage is abbreviated as NAS, N-A-S. Network attached storage is file-level data storage. It provides data access to authorized network users. Network attached storage is useful for storing streaming media from a central location. It allows for easy file sharing and access from different locations. NAS devices have multiple disk drives that are organized logically using RAID, mirroring, and striping. This helps to provide hard drive redundancy. NAS devices have high-speed data transmissions and frequently will use gigabit-sized network interface cards. File servers are centralized storage systems on computer networks that will allow authorized users to access data files. Administrators will define the file server access rules, the authorized user groups, and the data properties. Common file properties for users are adding, editing, or deleting files. File servers perform data backups and allow for the joint saving and managing of files. File servers will store file backups on a timeline that's defined by the system administrator. Backups can be daily, weekly, or monthly. File servers also have remote access capability. However, only authorized users should have this remote connectivity feature. Cloud storage is remote off-site data and file storage that does not require an on-site physical server. Cloud storage does require an internet connection to access the data. Cloud storage uses wireless signals to carry user data to and from. Users can access cloud services from both laptops and mobile smartphones. Many cloud services can integrate with your email and office applications. Some common cloud storage platforms are Google Drive, Microsoft OneDrive, Apple iTunes, and Dropbox. That will conclude this lesson. If you have any questions about the contents of this lesson, please review the course notes and exam objectives in Section 2.5. In the next lesson, we will cover Section 2.6 in the ITF Plus course, Common Computing Devices. We thank you for following along to this video. We'll see you in the next one. Enjoy the rest of your day, everybody.